Okay guys, time to try limiting reactant. And as you probably have figured out, we're not going to just do one problem on a video and expect you to be able to do it. We'll be doing these in class, and I'll be working a few on the board. I will have you be putting things up on the board from your homework, so make sure you bring your calculator, your book, your worksheets, everything to class so that we can get through this and get to the end of this chapter fairly quickly. So, limiting reactant. And again, it's kind of the question of which one of these is running out first, or which one of these gives me the least amount of product. Because the one that runs out first is the limiting reactant. So, an alkaline battery produces electrical energy according to the equation, and it's given there for you. Zn plus MnO2 yield plus water gives zinc hydroxide plus what would that be? Manganese 3 oxide. So, determine the limiting reagent if 25.0 grams of zinc and 30.0 grams of manganese dioxide are used. So, or manganese, what is that? 4? Yeah. Okay. So, let's start. We will start with 25.0 grams of Zn. We're going to set up our theoretical yield calculation. And I looked up some masses, and I have them written down so that I don't have to do all of that. We will do it plenty of times in class. Trust me, you will not. This will not be a mystery. So we have 65.409 grams of Zn for 1 mole of Zn. In this problem, they want me to figure out how much zinc hydroxide is going to be made, so I'm going to do my theoretical calculation going to that product each time. So, for every 1 mole of zinc, I get 1 mole of zinc hydroxide. And I looked up and calculated the molar mass of zinc hydroxide, and for every 1 mole of zinc hydroxide, the mass for that is, where is it, 99.425 zinc hydroxide. So let's calculate this out. So again, I like to clear it. You don't have to. So it's going to be 25.0. We're going to divide that by 65.409. We're going to multiply and divide by 1, and then we're going to multiply by 99.425 equals, and we get 38.00 grams. And I am going to carry an extra significant digit here. I'm not going to round at all. I just want to see which one of these runs out first. So there's my first calculation. Now I have to do a second. Complete theoretical yield calculations. Are there shortcuts? Probably so. Is this problem simple? Absolutely. Should you take a shortcut? Absolutely not. If you do, eventually it will catch up with you. I am showing you the way that will always work. I would suggest you do it that way. If I have to do it that way, I'm guessing, although you may be smarter than me, you've not done as many problems of these that I have, and therefore if I tell you this is the best method, you might want to listen to me. So, starting with 30 grams of manganese dioxide. And I looked up the molar, or calculated out the molar mass for that, and that's 102.94 grams of MnO2 for 1 mole of MnO2. And then we have 2 moles of MnO2 for 1 mole of zinc hydroxide. And from this point through the end, it's exactly the same as the previous calculation. The beginning 2 steps are different, but the ending 2 steps are very much the same. So 1 mole of zinc hydroxide for 99.425 grams of zinc hydroxide. And again, we need our calculator. And so we're going to start with 30. We're going to divide by 102.94. We're going to divide by 2, since that 2 is in the denominator, and we will multiply by 99.425 equals, I get 14.487. So let's write that down. 14.487 grams of zinc hydroxide. Now, the only question to ask yourself at this point is which one of those two numbers is smaller? And that will answer part B. And by knowing which one is smaller will tell us which was the limiting reactant, zinc or manganese dioxide. Well, 38 is larger than 14, so my limiting reagent, and I use LR, equals MnO2. And so that's the part A answer. The part B answer is going to be, I can make this much. I have 3 significant digits, so I need 3 here, so that's going to be 14.5 grams of zinc hydroxide. There are my 2 answers. This could be combined with a part C that asked you what is the percent yield if it only made a certain number of grams. So I hope that helps. That brings to an end the calculation or problem videos, and we will be doing lots of these in class. So hopefully you will have a lot of practice before you have to do this for your test, and you'll actually get to do some labs with this. So until next time.